All right, so welcome to a statics problem in which we solve the centroid of this little figure we have right here. Now, we have two curves here that give us a shaded area, and we want to know what the centroid of this little shaded area is. And we have our intersection right here where these two equations meet at a comma b, and I denoted that as a coordinate. So we want to know what the centroid of this little shaded area is. Okay, so we're going to solve for that. Now, as you recall, our centroid of any coordinate, let's just say x, the coordinate of our x component, for example, is the integral of our x coordinate of a cross-sectional area that we create divided by the integral of our dA. So we're going to save this equation for later. I'm going to keep this up here for a little bit. Now, we actually don't have this equation given to us. We know what this equation is. It's given as x equals ky squared. We just don't know what this one is. Now, we can actually solve for that. So how do we solve for that? Well, we can just take two lines. Apologies for the non-straight lines, right? And we can label these as an x coordinate and a y coordinate. Now, we can kind of see that, you should see actually that there are two triangles right here. So we have a triangle that is a constituent of x and y, and then we have a triangle that has constituents of a, which is this length right here, this is A, and our B, which is this length. Okay? Now we can solve for a geometric law that we know, the similar triangles. So let's solve for similar triangles. So we have x over A, right? This branch and this branch are congruent. And then we have y over B. Okay, and then we can solve for x. So therefore, in this case, x is equal to yb over b times a. Okay, and I can box this if I want, but we'll leave that there for now. Okay, so now we have the equation of this line, and I'm gonna erase some of this stuff right here. Just to make it a tiny bit neater. Okay. Now, actually, we don't know what k is. K is some multiplier, but we don't know what k is. We can solve for k too. So let's go ahead and solve for that as well. So let's pretend that x is a coordinate a and y is a coordinate of b, because that's a coordinate that we know. Okay, so let's suppose x is equal to a and y is equal to b. So now let's try to solve for k. So replacing our variables here with x equals a, we have a equals k b squared. Okay? So therefore, if we solve for k, we actually end up getting this. K is equal to a over b squared. Okay? All right, great. So we're going to keep these two pieces of information in mind. We're going to need them later. Now let's go ahead and solve for both of our coordinates of the centroid. So I'm going to make a cross section with respect to y, and you'll see why in a minute. I know that was a bad joke, but this is going to be our height right here, dy. And then what is this distance right here? What is our base of this cross-sectional area? Well, if you notice, it should be this equation, which we found to be this, minus this equation, which is this curve right here. So we have this equation, and I'll replace x with in terms of y, because we made our cross-sectional area in terms of y. So we have y over b times a minus this equation, which should be ky squared, but I'm going to replace k with this value right here. So k, as we said, with a over b squared times y squared. And this is our dA, and we need to multiply that by dy because this is our base. This whole thing right here, this is our base, and then this is our height. So I'll just say b as base, h is height. Okay, so that's our dA. Now, let's go ahead and solve for the area of this whole thing right here. So the area should be the integral of all of our dAs. Okay, now what are our limits? So let's say we're adding all of these rectangles from starting from this point right here, which is 0, all the way up to b, because we're doing it with respect to y. So 0 to b, I'm going to put these as our limits here. Okay, now let's go ahead and solve for this integral. So we're going to have the integral of 0 to b of ya over b minus a over b squared times y squared, and all of this times dy. Okay? All right, so now let's go ahead and solve for this integral. I'm going to scroll down a little bit here. So this should be, if we integrate, I'm just going to go ahead and integrate with respect to y. So we're going to have a over b, and if you need to brush up on your integration skills with polynomials, I highly suggest looking at a video or two how to do integration of polynomials. So this should be a over 2b times y squared minus a over 3b squared times y cubed. And we're evaluating this with limits 0 to b. Okay? So let's go ahead and solve for this. So we're going to plug in our b first. So we're going to have a over 2b times b squared minus a over 3b squared times b cubed minus plug in y equals 0. Now if we plug in y equals 0 for both of these terms, they're actually going to result in 0. So I'll just say it's minus 0, but just to keep in mind that you still need to evaluate at 0. Don't ever forget about that. Okay, so let's actually simplify this a little bit because we can. Now we can get rid of like terms here. So b squared, and then we have b squared over here. We can get rid of this. So to simplify, this should be ab over 2 minus ab over 3. Okay? All right, so now we can actually simplify this even more. If we combine common denominators, we should end up getting ab over 6. Now I'll leave the algebraic steps to you. Just for the sake of time, this is the result of our dA. So that's our total area of this whole thing right here, okay? So this is our integral of dA, so we're going to need that later. All right? So now let's go ahead and I'm going to erase some of this stuff right here. And we're going to solve for our x-coordinate first. All right? So in order to do that, we need to know, as we have up here, what is our x bar? Now x bar is our x coordinate to one of our cross-sectional areas of the centroid of one of these areas right here. So how can we find this? Okay, well, we can say that this distance, we need to know what this distance is, right? Can't we just say that this distance is this equation plus half of this distance? So that kind of sounds tricky. Let me write it out. It's going to be our ky squared, which is this distance to this curve right here, plus half of this distance. We already found this distance to be aby squared, or actually this distance is actually this guy right here. So it's going to be ky squared plus half of this guy right here, right? So let's go ahead and write that out. So y over b, a minus a over b squared times times y squared. All that is divided by 2. Okay, and this should be our x bar. Now that's a handful, right? But we can simplify that, right? So why not? Let's go ahead and simplify that. So we can replace k, as we said before, with a over b squared. So a over b squared times y squared plus y a over 2b. I'm going to separate these out as two separate fractions. So we have a over b squared times y squared, then divided by 2. Okay, now we have two terms that we can combine here. We have this term right here. Forgot to add the plus sign right there. And this term. So if we combine these two like terms, we should end up getting ay squared b squared, or sorry, not b squared. Yeah, it is b squared. B squared times 2 plus y over a over 2b. Okay? All right. So that is our x bar. Don't forget. I'm going to write that here again. Now I'm going to erase this a little bit. So now let's go ahead and solve for our x coordinate of the centroid. All right. So our x coordinate of the centroid, I'm going to need a lot of space here, is going to be, now I'm going to rewrite this equation just for the sake of us referring to it. So x bar times dA, integral of that divided by the integral of dA. So let's go ahead and replace all of our variables that we have here. So our x bar should be this guy right here. So it's ay squared over 2b squared plus ya over 2b plus ya over 2b. Now this is the integral from what again? 0 to b, because we're going to do it with respect to our y, and you're going to see in a minute, times our dA, and we said our dA is this. So let's go ahead and replace that. So ya over b minus a over b squared times y squared times dy. All right. And then this should be over our integral of dA. And we already solved for this. We already solved for the integral of dA, which is this. But I'm going to replace that later. And just for now, I'm going to keep it as the integral of dA. But we're not going to forget about it. Okay. So now, if we go ahead and solve for this, we're going to have to FOIL over here. So that's going to take some algebra. It's going to take a few steps. Now, I didn't write out what this is simplified to. So we're going to have to go ahead and simplify this out on paper right here. So let's go ahead and FOIL right here. So we're going to have a squared y cubed over 2b cubed minus a squared y to the fourth over 2b to the fourth. Okay, and then we have plus y squared a squared over 2b squared minus, hopefully I have room to write all this, y cubed a squared over 2b cubed. Okay. Now all this is multiplied by dy, and I'm going to put this with an arrow because I don't have room. Actually, I can scroll. I forgot about that. Okay. Times dy. Now, this kind of looks intimidating, right? It looks like a long expression. But, however, we can actually see, and hopefully you recognize this, but we can combine like terms here too. Now, what like terms are we looking at? Well, we have a factor a squared y cubed over b cubed right here as one term. And then we see we have another one of these. And it's exactly the same thing. It's a squared y cubed over 2b cubed. And we're subtracting it, right? So we can see that these terms should actually just cancel each other out. That is great. We just now simplified our solution. So I'm going to write it down here. I know that was a bad Latin S. So it should be minus a squared y to the fourth over 2b to the fourth plus y squared a squared over 2b squared. Okay, that looks a little better, right? Not entirely better, but a little bit. All right, over the integral of dA. Okay, now let's integrate this top portion right here. Okay, so with respect to y, this integral should be a squared over b to the fourth times y fifth, y with an exponent of 5. Now if we divide our 5, I'm just gonna make this a 10 because we're multiplying 2 times 5 in the denominator. Okay, and then this is also negative, so don't forget about that. I almost did. And this should be y cubed over 6 b squared a squared. And we're evaluating this from 0 to b over our dA. Okay, we're almost done. All right, now let's just plug and chug here. All right, so this should be, we plug in our b equals y. So we should have a squared times b to the fifth. Now b to the fifth over b to the fourth just simplifies to b. So I'm just going to leave it as b in the numerator over 10 plus, now if I plug in b here into y cubed, it's going to be b cubed over b squared. So it should just simplify to a squared b in the numerator over 6. And if we plug in 0, these terms should be 0 because 0 in the numerator should result in a 0, so it's going to be minus a net 0. divided by our integral of dA. All right. Now let's go ahead and simplify this here. We have like terms, so let's go ahead and combine those. So it should be, if we simplify this, it should be, now if we get our terms to be a common denominator of, let's say 60. Okay, so we have 6 over 10, negative 6 over 60, plus 10 over 60. So it should be this. It should be 4a squared b over 60 times or divided by our dA. So what was our dA? We said that to be AB over 6. Okay, so we're dividing that by dA. So let's multiply by the numerator. So it should actually be, instead of AB over 6, we'll flip the reciprocal, and it should be 6 over, sorry, not over 6, 6 over AB over AB. Okay. All right. So this is a 6, not a B. Don't get confused. All right, so now we can actually cancel some terms out here. So we can cancel out these B's. We can cancel out an A down here and one of these A's up here. This should be 1 over 15. So we have 6 over 15A. And that should contribute to, if we simplify this, this should actually end up being 2/5 A. All right, so after all of this work, we get our x-coordinate of the centroid to be 2/5 A. All right, great. That is the first part of our video. In the next video, we're going to solve for the y-coordinate of our centroid. So hope you stay tuned and watch that one. Thank you. Goodbye.